Hey everyone, welcome back to 30 Days of Python. Today's day 13 and we're focusing on list comprehensions. We have gone over loops before. This time we're looking into making them more efficient, readable one-liners. Let's get into it. Let's compare the traditional looping methods with what list comprehension is, and we can go from there. We'll start from something simple, like creating a list of squares. Using a for loop, we can see that we specify variable number to represent the current value inside the list numbers. And for each number inside numbers, we update or append the current value by squaring it. The output will be a list of squared values from the original list numbers. We get this since we've been through this before, right? So we do get this. Now let's look at the list comprehension method. The same concept of what is meant to loop through, only now implemented in one line. All we are doing now is specifying the same thing inside the empty squares list, taking the original list numbers and squaring each value inside that list while filling the squares list at the same time. The difference now is instead of 4 lines it took to output the traditional method, it only took 1 line to get the same result. From what we see, list comprehension is more concise, less code to write and read, more readable, making the intent clear, faster as it's optimized in Python and more Pythonic. There are 3 main points in list comprehension. A simple transformation, basically the same as we did in the first example. A string operation, same as before with the integer values, but we can still use the basic string function while looping through the list. We can work with ranges as we have done when we've addressed loops in previous days, and do more complex expressions like finding the length of each name in the list of names. The pattern remains the same. What you want for each item in where to get it from. It's now descriptive. You describing what you want, not how to build it. When you want new clothes, you say what clothes you want, not how to design it, tailor it, or sew it before buying new clothes. Unless you are that person, then good for you, I guess. Let's go a step further and start adding in conditions. You can filter which items get processed using the if statement. Like this example. We can use the if statement in a similar fashion in the one line like we did with the loop here, as if we have it nested in the for loop. We filter using the if statement. It is nested in the for loop, however not in so many lines as the list comprehension allows us to put it in one line. The conditional can go at the end of the line for simple filtering, or it can go at the beginning for conditional transformations. Now we look at nested loops in comprehension, making light work of complex operations. This is probably what you've seen experienced programmers use in their code before. As we know, traditional loops will take 4 lines of code roughly, while nested loops will take another 2 lines, and if you were to add in an if statement, more lines of code is used. As seen with list comprehensions, we can do the same with nested loops. Just note this, the outer loop will be read first, then the inner loop. Like the multiplications table, we specify the variables of each loop, I and j, multiplied by each other for value of each row multiplied by the value in the list, or in this case the range from 1 to 5. For dictionaries and set comprehension, it's pretty straightforward if you grasp the concept of the list comprehension. With dictionaries, keep in mind that you have a key and a value. So you must indicate the key as seen here with X colon, then the value following that. For sets, remember the basics of sets. No duplicates will be looked at, which means in this example, when trying to determine the length of each word in the set, the output would be 5 and 6 rather than counting the length of each word. So remember, a dictionary comprehension uses curly braces with key value pairing, and the sets use curly braces with single values. The principles are the same as the basics of sets and dictionaries. Let's take a look at some real-world applications. It proves useful for things like data cleaning and processing, like the first example here. In the list data, we have odd data that has lower caps, spaces, upper caps. If we were to call an item in the list, let's say banana, we would need to call it by the correct naming convention in upper caps. But if we were to just type in lower caps, an error would be thrown. That is why in the second line of code, our comprehension takes place. We specify that the fruit in the list must be taken out of the list and put into all lower caps regardless if they are in lower caps or not. It then would iterate through the list and store the new list in the variable cleaned, which would output all values in lower caps. We can also use this for extracting specific data from objects, like checking if the user is active or not, by extracting the name of the active user if the key active is true. In this case, it would be just Charlie and Alice. This is used in bigger data structures in the real world, like the example of checking a user's subscription before allowing them to view the website's dashboard that only paying subscribers can view, for example. The next practical example would be to extract data from a file, like a CSV file. If you know, in a CSV file, it is separated by commas, like the list lines. So imagine reading lines from a file that you know is supposed to have columns but doesn't. So in this case, we split the list up by specifying the line be split by the comma and placed in the first index, which is 0. The second index will contain the rest of the line. Now everything before the comma is in a new list, fruits. We do the same thing since now the list lines still contains the comma. We split the list by the comma and specify that we want to send the second want to put it in the second index value, which is the integer value. However, we need to convert it to an integer since it's technically still a string value, hence the use of the int to convert it. Now the list lines will still contain the list as it is, but we created two new lists, fruits and quantities. These patterns come up constantly in proper Python code. Once you find comfort in dealing with comprehensions, you'll be using them in most of your code going forward. So we know when to use list comprehensions, but when shouldn't we? It's most likely that we will get overconfident and start using it everywhere all the time, like someone learning a new word and trying to find a place in the conversation to use it, right? When using comprehensions, try not to be too complex with things. Take this example here. It's too much to comprehend, hence comprehension. If you can't explain it to yourself, then it's too much going on in one line, and it's best to be split up going the traditional route. We haven't touched the concept of big O notation, but having too many nested loops can slow down your code. In the case of comprehension, we know it's easy to see the inner loop or the inner loop by the means of separating with the square brackets and then the inner loop with another square bracket. Then the outer loop starts. It can become confusing when you need to refer to a certain loop. Then it is best to break up the loops and use it separately, or use one nested loop and just loop the third normally. Keep in mind, using comprehensions when the logic is simple and clear, when transforming or filtering data, or when the comprehension fits on one line comfortably. Stick to traditional methods when it gets complex, or when you need multiple statements, or when it's simply unreadable. There are benefits for using comprehensions, like the need for speed in processing the Python code. It is optimized at a C level in Python, making them significantly faster, especially when dealing with larger datasets. It proves very useful in a DevOps environment, dealing with a large data server. In this example here, you can see the amount of lines that need to be read through for the Python code to execute successfully. Whereas the comprehension method of looping uses 4 lines of code. We're taking the loop and placing it inside the declared list result. So instead of first declaring an empty list, we just do the loop inside the list, saving time. So think of large data tables with a large data set. In order to loop the traditional method, it takes time. With comprehension, depending on the data set, the code is processed faster. That is it for list comprehensions. This will make your code look more professional, efficient, and Pythonic by all means. So I hope you've gained something from this video. Please consider leaving a like and clicking that subscribe button. As we continue on with this journey, we move on to day 14, where we will tackle high order functions. Cheers guys, I'll see you then.